Good afternoon to everyone. It is a great pleasure to welcome the fifth day of six-day faculty development program on Bridge Education and Intelligence, jointly organized by Department of Computer Applications and PG Research Department of Computer Science, Nandha Arts and Science College Autonomous Erode. Today topic is multimodal deep learning. Now I request Mrs. T. Baby Ma'am, Assistant Professor of Computer Application, to deliver welcome address.
Intelligence and innovations are at their best when guided by purpose and patience. A very pleasant day to everyone gathered here. With immense respect, I welcome you all to this fifth day session of our faculty development program on bridging education and intelligence. At the outset, I extend my heartfelt gratitude to our beloved principal, Dr. S. Manogran sir, for the concerned support and guidance have been instrumental in making their program a success. A special welcome to S.N. Santalakshmi ma'am, Head Department of Computer Applications, and Dr. P. Parimalam ma'am, PG and Research Department of Computer Science, for their unwavering support and valuable contribution in coordinating and facilitating this FTP. Today, we are deeply honored to have with us our esteemed resource person, Dr. Thilagaraj, Associate Professor in Data Analytics and Mathematical Science, School of Sciences, Jain University, Bangalore. Sir, we are delighted to honor you with us. Your experience will surely enlighten us on today's highlighting relevant topic, multimodal deep learning. On behalf of our management, respected principal, and the organizing team, I extend a heartfelt welcome to you, sir, and all our esteemed participants. Wishing everyone an insightful and inspiring session ahead. Thank you.
Thank you, ma'am. Now I invite Ms. G. Anita, ma'am, Assistant Professor in Computer Science, to introduce our chief guest.
Good afternoon to everyone. It gives me immense pleasure to introduce our esteemed chief guest, Dr. Thilagaraj sir. Sir has completed his PhD from Babla University in 2022. He has served in various reputed institutions and has over 16 years of teaching and research experience. He has published more than 20 research papers in reputed international journals. In the year 2022, he got a UGC travel grant to present his research paper at an international conference held in Malaysia. At present, Dr. Thilagaraj sir is serving as an associate professor in the School of Sciences, Jain University, Bangalore. Now I happily hand over the session to our chief guest, Dr. Thilagaraj sir. Thank you, sir.
Thank you, madam.
The
First,
time to hand over the section to our chief guest, Dr. T. Thilagaraj, sir, Associate Professor in Data Analytics and Mathematical Science, School of Science, Jain University, Bangalore. Sir, the session is yours.
yes. Madam, am I audible? Hello?
Yes, sir.
Yes, sir. Thank you. Okay, nice meeting all you. Good afternoon to all. First of all, I'd like to thank my professor, Dr. S. Manogaran, sir, principal, Nandha Arts and Science College, and my professor, Pamela Madam, for giving this opportunity to act as a resource person in this FDP. And I thank all the organizing team for giving this wonderful opportunity. And it's been a great day. And we will go to the session now. And I will share my PPT. We'll see. First, we'll see. Yesterday, I hope you were designing concept, and this is the right time to go to deep learning. And I will first we will see about that. What is deep learning? So the term itself, deep learning, is it means going much deeper and learning more. So that is a main thing. And when we talk about this deep learning, we want to know about that neural networks concept. So generally, how this deep learning have been made, how it comes means, it actually mimic from the human brain. So this it's a combination of how our brain will works. So like the same strategy, uh, uh, deep learning have will also have implemented. So in that, it's mimic the complexity of the complex functions of the human brain, how we are, how the neurons are there, like that. We here also the same architecture have been used. So when we are talking about the neural network, so this wanted first we want to see about this biological neuron. So I know that this when we are going some for why I'm going with this concept means few of them are very new to the deep learning means then don't worry. With this we can definitely you can understand this. So I will go with the basics. Then we can jump into the unimodal and multimodal like that we can go. So first we want to understand what it is. So this biological neuron, how it is there, how here input signals will be received by through the dendrites, and it will goes to the cell nucleus, and it will be passed through that axon. It will be passed, and output signals will be done. So this is the this what the human brain will work. So like that, our here the neural network concept is also it will be framed. So here the inputs will be received and this node will be there. So same structure only. So how the dendrites will receive the inputs in the human brain. Likewise here this input, this is the input node. It will be receive the inputs, and here with the input we will add some weight values. So weight values will be added and it will be processed. So inputs weight along with some calculation will be done. So input function, that means summation will be done and finally activation will be done. So this artificial neuron will represent that normal how the biological neuron will work. Same thing will be done here. So that is the main thing. When we are going for a neural network, that we wanted to understand that perceptron concept. Perceptron in sense we will get an input. So before going into the multimodal, we want to understand how the structure will work. So that is the main thing. So that inputs will be passed. Input will be represented from x1 to xn, and weight will be represented from w1 to wn. This is the normal weight means. It will be automatically in while going for a deep learning model. Weight will be assumed automatically by the models. So here this inputs will be done. Inputs will be feed from the feed into the model. That means, for example, if it is an image we are taking, image each pixel that ranges will be passed as an input. So that's it actually. So along yes. So then weight value will be added. So along with that weight value will be added, then that represents this Z. That is a code. And one more thing, this bias will be added. So that is also bias B is a term is there. The bias will be added. So this will be done, and then it goes. Then we want to know about the activation function. So once we get an input and the weight value added, that added along with that what multiplied with the input and weight value will be done, then it will be cumulatively sum, then it goes for that, finally we will get our value, that finally the activation will be done. So this will be happened. How it will be activated if the value is a range. For example, different activation functions are there. I will tell you what are the activation functions. So mainly this actually ranges. If it is greater than 0 means one will be assumed activated and one will be assigned. So it will be passed to the output layer. So like that, this is the logic behind the deep learning. So how it will work. So then we are going for a that basic structure we wanted to know means input layers will be there, weight will be there, bias and activation functions. These are the main structure, main components included in the structure of the perceptron, and output and training algorithm will be implemented. So this is what this algorithm will work. I will show you some examples. So how this perceptron algorithm will work. Here, for example, threshold value means we can fix the threshold value. So based on, for example, if one we can take one example. I will show you that in I having then practical programs also there. So I will show you. So inputs will be there and weight will be there. So it will be multiplied and we will then some values will be calculated and cumulative sum will be there. If it is greater than, that means if you are having a threshold value, if it is greater than that threshold value, then that particular activation will be done. That particular class will be activated. So this what I will show you some. See, I having a practical exercise programs we having. Actually, I usually this deep learning when you are going for a coding and when you are implementing collab is a fine. You can go with the collab, and for small data set you can go with the collab, and if it is larger data set then you want to go with the Studio, you can go with like that. So here, see the same concept. If you see, uh, concept have been implemented here. So this was the activation function. If it is greater than 0, then it will return the 1, or else it will return the 0. So for example, one small example, if we assume it, for example, if it is different scenarios is there, that means whether friends or money, whether that person can go out or stay home, like that. So for example, if you are thinking, we as our human brain, how we will take some decisions, uh, for example, we will check whether is good, fine, we can assume the values of 1. If your friends are coming, the value will be assigned as 1. Money is there, then we can go out. So like that, that perceptron concept will also work. So based on that situation, that models will work. So this is what the deep learning will work like this. So, in between, if any of you having any doubt, please ask me. We will discuss. This is a simple program for implementing the perceptron concept, and different scenarios I give. Whether that person can go out like that, likely to go, maybe go, or may go, don't go. That means nothing is there. So nothing, money is there, no friends, no weather is also bad. So inputs will be assigned as a 0 0. Then it recommends a don't go. So based on these scenarios, so it will be what logic will works. So this is a very simple example. If you see that, then yeah, see that this is an Python code for algorithm. Then see, this is a logic how this deep learning will work. Then when we are going for activation, how this will be activated will comes to the live. Different activation functions are there. Step function will be there. That means if it is very simple, that means threshold value, fixing the threshold value. That means if it is we are getting input and we are adding a weight value, that means weight value manually we can do for our program, we can do, but usually these models will take a weight value automatically. So weight value multiplied, and that's cumulative sum, then with the threshold value will be checked, then in that scenario we can go with the step activation. And these are the, when you know about these activation functions, then it will be very fine. So here sigmoid activation function is one type is there. If it is a binary classification, whether I having an output, whether I can go or stay in home, two classes, only two classes, whether male or female, true or false, like that. If I having a two choices, like that is binary classification, then you can go with the sigmoid activation function. Or else if it is multiple classes there, I having an example, I kept it, all these things, note these terms. If you are very new to deep learning, don't worry, this is simple, these are the terms you want to keep remember, then it is very easy. So softmax is the activation function if it is a multi-class, and the relu is one more thing, it will be implemented in the hidden layers. So these are the activation functions. So these are the things are there, and we will see how it will be implemented. And this is a single layer perceptron. So this will be added, inputs will be there, weight will be there, and so this are before we have seen, no, same thing. That this activation, this is some cumulative sum will be done, and this sigmoid function activated it will be activated. So this what single layer perceptron will work. In case this is a multi-layer perceptron. Uh, so it is okay, madam. Am I going fast? Anyone can?
Okay, sir.
Okay, madam. Okay, thank you. So multi-layer perceptron. So if it is multi-layer perceptron, we will see this is the inputs. We will get an inputs, and here more hidden layers. Example, see if you our human brain how it will work. Means sometimes we will think one time and we will take a decision. Sometimes we will think more, one or more times. For example, whether we can go for shopping or not. If it is two times, we are thinking whether tomorrow we'll go or day after tomorrow, or else based on the scenarios. So that thinking means if it is two times, we can add two layers. three times. So how many times we can decide how many times this neural network logic can think. So it is completely, this hidden layer is used for is to think once or twice or thrice, like that it will work. So we having a bunch of it, we are passing into the network, and we having a bunch of hidden layers. In that, if it is hidden layer thing, and finally it will produce one output, whether we can go or not, like that, one or more, it is possible, because we can say more than one is also possible. So output is, that is called multi-class. So those things is possible. So this is what the hidden layer role is. A hidden layer, this is the role of hidden layer. And if you are understanding the weight, how it will works means, see, input, if we are calculating one new node, this is called node, we will tell, and this weight value will be updated here. And in case if that particular one hidden node, this node will be activated, then all the inputs will be considered to activate one node. For example, this hidden layer 2, that is second node, if it is activated, all the nodes will be activated, all the input nodes will be considered, like the third. So this what this logic will works like this. So weight will be done and hidden layers will be done is there. And for example, we if you see now with this example, you can definitely, you can able to understand. For example, I having an image, a handwritten image, it's called zero. This is an image I having. If I'm sending that image inside in the network, neural network, it will be passed, it will be passed to the internet, sorry, input layer, and it will be, it will be what, it will be divided. That means the input image will be divided and it will be passed to the hidden layer. So finally it will be passed like this. See how this different four portions will be passed. And one more thing we wanted to, I would like to tell that we wanted to decide how many nodes we wanted to keep it in a hidden layer, how many layers we want to keep, so that we can decide. So it's our choice. So we can decide the number of nodes we can keep it. And because when we are thinking about all these things, who will input nodes, we can't decide, the inputs will be received automatically, but in a hidden layer number we can decide, and nodes we can decide. So with this this is a thing actually. So with this this is a portion of image will be passed, and it will be finally, if it is based on the weight and activation function. Here if you are, see, this is a multi-class, because multi-class in sense 0 to 9, more than one class is there. 0 and 1 if it is okay, here numbers means multi-class. 0 to 9, it's a 10 classes is there. If it is alphabet, if you are going with a alphabets, your handwritten digits, alphabets, if you are going means, then that time you wanted to keep 26 output, 26 classes in the output layer. So usually it will goes like that. So here this is a mechanism will go, what input will be passed, and it will pass to the hidden layer and it will be activated. And see that this is a very simple example with this real what many of the images human faces is there, and I'm sending on image. For each and every image we are sending it in a hidden layer. We are having a 3 hidden layers, nodes, different number of nodes we are keeping. And finally we are having a 3 classes, 3 persons we wanted to find, which whether it belongs to. So I'm sending some images, and if it is passed, and it finally it will activated, this particular class will be activated. How it will be activated means, if your this particular class will be activated based on the scope. Usually in output layer, softmax activation function will be used actually. Sorry, softmax activation function will be used. So in that case, based on the scope, because which class have the highest scope. For example, we are sending images, we will all class get some score, but which score is the maximum score, that class will be activated. So based on we are using softmax, okay, fine, that output layer. But even though that based on the not only softmax will decide based on the highest probability. So this is what the deep learning will works. I hope some of them, because directly we are jumping into the multimodal. So I just I have some few things I have explained about this deep learning, how it will work. So you will get some idea, I hope. And one more thing, machine learning and deep learning, if you are comparing that, what is the difference? It means the main difference is features will be extracted separately in machine learning, and classification both are separately, it will be done in a different stages. But in case in the deep learning concept, both will be done together. Feature extraction, classification, all together it will be done. So this is one of the advantage when we are going for a deep learning. Now we'll see. So what is unimodal and multimodal? First, we will want to understand what is unimodal. Unimodal in sense process one type of data. For example, only text data, only image, or only audio. So that means I'm sending only one type of data to that neural network. We have seen now that how this neural network will be that architecture will looks like. So we are sending one type of data, whether text or image or only. It's called unimodal. So when we are using this unimodal category, what is the disadvantages means? Because see, when we are going for a real-time real-time applications, see for we will not reach that much of result, because of, why means see, with a single type of data, we can't take a decisions. For example, only with the text, with the medical related to the medical applications, only with the text we can't doctor that models can't predict. Some images relate, if it is MRI images or some X-rays. So like that we need it, because this is the main thing. So I hope with this unimodal, I hope you understand that. If it is unimodal in sense, these are the applications. That means text. I having a sample applications. Just process NLP. I hope you having some idea about NLP. For example, if it is a natural language processing, if we get into the topic, only classifying the text, we can use some LSTM or whatever algorithm we can use. With that, we can do the classification. So only text will be classified, or image it will be separately. So this is a booming area. So multimodal data is nowadays all the researchers and many of them applications are developing using this concept only. They are working, and see what multimodal data refers to the data collected to represent the multiple modalities. That means different text, audio, image, or video, sensor data. So all these things we are is combining. It is difficult, very difficult to combine all these data, but maximum we can try. Slowly we can we work with as text or audio. I will show you some example. I having this example. One example is there. See here, images, same thing, Google Colab, I go. So here, three images are there, and the three images, I'm adding some text. With when we are seeing that image, we can easily understand which is cat, which is dog, and which is apple. But when we are going for an machine translation, then it is difficult. So here I'm adding some text, so we can we can add the image, we can add text to that image, so that is possible. So simple text we can give, and finally we are, if you see, I'm just adding, for example, this is a cat image. When we are going for a three images is there, no, three classes, it will be activated. In that, score will be 0.983 will be the cat. So it will be pretty, and I'm telling the score value, how much, whether which image, and I'm just adding the text. So we will get some idea. I hope we are bringing some text, and we are finding the score value. So we are manipulating with that. That is a logic. The dog in this image, dog score is 16 only, 0.016. If it is a picture of the apple, 0.01, like that. It is, there is no like that score value we can predict. If it is a dog, in sense, see here, dog score will be high, and if it is like that, we can do that. This is a very simple application. And one more application I having for this is for apple. It's perfectly uh, classified that score value, we get a score value, highest score value. So this what we can add, this text part I'm adding. And so one more application I having here, we are processing audio and text. If you are looking into the multimodal audio and text, we are combining in sense. For example, this is an NLP sentimental analysis program application. So we are not going to the NLP. So this is, we are dealing with multimodal data. So I'm just processing the different types of data. So this is on data, and I will execute it. See. This is on audio I'm uploading here actually. So combine the text audio, and here I having a two text actually. Two in audio I have recorded one, or what is the content means. I'm You are not good, you are aggressive, you are not study well. So this is my content in audio. So it will be converted to the text. So through NLP it will be converted. And here the user text is, I have added one text that's called, I'm very excited to learn multimodal AI. So these are the two text I'm getting a one type of data I'm getting from an audio, another one type of data I'm getting from a text, that is I'm keeping myself in a text format. So just this is combining this thing. I want to do a sentimental, whether it is positive or not. Here combining these two. So you are not good and aggressive or not. I think some negative words is coming high. So the score value for negative, it's sentimental result is coming negative, and score value is high. This is a score value. So like that we can predict based on the audio and text. We can do all these things. So this is what multimodal data. So we can combine the text, audio, and the images, video, sensor data. All these things we can do. We'll see. So mainly how data integration we want to do. So we want to do the models use algorithms to combine data from the different sources. Definitely when we are processing audio, we want to separate. We want to use some other techniques. Processing video, some techniques will be differ. But finally we are combining. Feature extraction will be done here. Joint representation, combining the different features from the different model, the joint representation will happen. So this is what the multimodal will works. And once we are going for this task, we wanted to understand about the fusion. And there is a different types of fusion is there. Early fusion, late fusion, and hybrid fusion. Early fusion in sense, when we are sending a data, and we are concatenating the raw features before feeding into the single model. So when we are doing for example, different, I will show you. Okay, before sending we are implementing, for example, we are using CNN or some deep learning algorithms, ResNet or MobileNet, whatever model we can use. So before implementing that, we will make the fusion. Because if I'm using, for example, before we have seen on program, no, that in that program a text data will be received and audio data. This fusion will be done. After that only we will implement some model. So like that, that's called early fusion. We will combine the both extracted features before implementing the deep learning model. That's called early fusion. And late fusion means we will implement once we extract the features. We fit some deep learning model, and after that deep learning model will give some result, and after that we will do the fusion. So like that, different from audio, I will extract feature, I will implement some model. Likewise text, I will implement some, extracting the features, implementing some deep learning model or some other model. Then finally, after implementing the model, if I'm fusioning, that means combining the features, combining the data. That means output means it's called late fusion. Hybrid means mixing of both. So early and late fusion, that means what? Combine essential. For example, in one model we can do early fusion. In another one approach, if we feel that some model should be implemented before doing the fusion, before going into the next level, we can implement. That's called hybrid fusion. These are the three fusions we wanted to understand about when we are working in the multimodal fusion. Three types, only these three types it will work. And this is a simple architecture. Input, we will different inputs will be there, and in that deep learning model will be implemented. We will get an results, and with that results we will do the fusion will be implemented again. Here previously also done. So the general architecture of multimodal, this is actually fusions will be done, then final predictions will be done. So this is what the architecture will goes. So I hope you get some idea about this architecture. So we will implement some model and fusion doing, combining all these features. And see, I have shown, I hope sample applications we have seen, text and image, audio, video also we can do. So as much as possible. So whenever we are combining, we are working in the real-time application, we must be very careful then when we are extracting the features, or else we are using some models. We want to be very careful because when we are dealing with that multimodal, we should very careful in that phase. And example, for example, in cases healthcare, we can combine the MRI images and the patient history. That means text. It might be in a text, heartbeat rate recordings. So all these things we can combine it and we can do. In one scenario, one of the friend he told in one doctor and one analyst they had discussed, and one analyst found that based on the history of the particular patient, he told that he got a cancer, and he having the cancer actually in the but doctor is not agreed with that. In one case it actually happened, and in that this analyst what he done means he showed all the reports these models have detected properly, and they found it finally it's a first stage of cancer they found like that. So they finally there because that much accuracy these models can do. uh, uh, Not only that, because some in some cases it will predict accurately. So so this multimodal is having such a power. So that, and one more thing is here AI assistants like ChatGPT what we are using now, ChatGPT with visions, we can add some images, and we can generate responses like that. We are combining all the ChatGPT. It's I hope it's comfortably it's doing. And social media post also we can combine when we are going for social network analysis. So that in that case, text, picture, videos, and even audio clips, all these things we can combine and we can do. Lot of scope is there, and in few these are the applications we can have. Healthcare we can work it more. And here that smart cities, that means sensors. I hope many places we are using the sensors and video surveillance and NLP for the traffic and safety. Even though in a city like Bangalore, still the traffic issue is biggest problem. Um, but they are working. But this multimodal approach will help. But even though, uh, but the capacity and speed is the biggest issue in that system, sir. So cyber security, we can use log data, adding that network traffic, user behavior model. So all these things we can go with that. Once we are going, it's in our topic in our area as a faculty, then multimodal tutoring systems. So when we are having it now, we are facing lot of things in tutoring. I hope. So in that case, we can add text, speech, video, and based on the feedback, all these things we can combine, and we can do that. Tutoring systems also we can develop. So this is a simple example. And human computer interaction, that is speech, gesture, facial recognition, enterprise, all these things will work. And IT, the multimodal chatbots, decision supports, intelligent assistants. So all these are the areas this multimodal having the scope. And I have explained all these things. I hope. And what is the challenges in sense? Challenges in handling heterogeneous data. This is the biggest thing actually. When we are using a multimodal data, that's it will not directly match because we are telling we are combining all these features. If it is mismatching is highest possibilities are there. For example, audio we are adding, and some audio we are fitting in, try to fitting into the video that framework as accurately wanted to get matched. So that this is the biggest challenge happening. And missing modality in sense, one or data sources may absent. When we are going for a multimodal, if we are going for this concept, we want to serve more data. Here, this deep learning is the biggest thing. How much data we are serving to the system on the network, that much accuracy we can expect. Only that is only the way we can get a good results. Or else, if it is a less number of data, if some data is missing, so in that case, it is very difficult. For example, a patient medical record may have X-ray report, but no lab report in sense. In this case, if it is it goes like that, then this model will not predict properly. We must be very careful when we are going for a real-time applications. These are the biggest things, and synchronization is the biggest thing. If it is a audio is going in one, audio speed is in different and video speed is different, both it should be matched. So we want to be very, when we are going, before implementing this multimodal, we wanted to check all these things. That feature extraction, pre-processing, in the pre-processing stage, we want to be work more. So that is a main thing, I hope. And uh, with this, I think you having any questions, we will discuss. We'll take a time for the discussion. Yes, actually, I hope you get some idea. We will discuss it now, because why? If it is an afternoon time, if I going more in depth in the deep learning concept, I know very well. It is very difficult. So I just this is a multimodal actually. In scenario that nowadays a lot of projects have been uh, going in this multimodal concept. So this is the main thing. If you have any doubt, please we will discuss it. Mine actually, one more thing I like to tell about, in case if you are starting your research in deep learning, and one more thing, deep learning is, we are it is a nowadays research is going in a multidisciplinary way. So this actually in researchers, you can go with this multimodal concept, because whatever problem you are using, data is different types of data. We are only the area we want to focus is the pre-processing. We should do properly. If we do properly, then it is fine, because here this deep learning will work it will work good. We having so many algorithms, we in as per our situation, as per our requirement, many algorithms are there, it will be fit into that phase. Combining these features, it will we want to be very careful. So I hope you have you I don't like to go into the CNN. If it is more than this 1 hour, with this I like to conclude. So deep learning algorithms, you go through it, and CNN or ResNet or MobileNet. So how these neurons we have seen, that in that phase only it will pass. The network will be there and it will be passed. So in that case, uh, you can look into the multiple data. If you collected the data properly, then once if you collect, and one more thing I like, here this um, grants and all, this multimodal. If you are working in the multimodal, and if your grant research grants also you can get, so that you having a more opportunity in that when you are going for applying a grant. So this type of approach will help you. And mainly once you are collecting the data, you extracting the features and fine tuning all these things, if you've done, then you can whether you wanted to know about whether you fusion, which fusion you are applying, whether early fusion or late fusion or hybrid fusion, you want to decide about that. And extracting the features, then you decide this. If it is early fusion, no problem, then combine it and you can send to the model. Or else what you want to do means, you want to uh, uh, fit the model, generate the result, and late fusion also you can do. So definitely we will get a good accuracy. So once how many, that one more thing is how many hidden layers you are keeping, how many nodes you are using, that also play a game. So that while keeping the hidden, and one more thing, if you are increasing the hidden layer, it will time will also increase. Check it slowly, slow by slow. You go with that adding hidden layers and all. First you work with a one single hidden layer, then you add one more hidden layer, like that third hidden layer, like that, adding the hidden layer and adding the nodes also. The adding nodes in sense, how much size of data, the batch size, how much you are sending to the network, that will also erode. So here biggest thing is time. So we wanted to very careful where time perception is the most important when you are developing a model or implementing a model. In these phases we wanted to set it properly. Once we are setting all these things, and then it will work fine. This collab is fine working when you are, if you are assigning the projects to the your students or something. A collab using a deep learning, implementing deep learning, collab will help you. Definitely this we're comparing to the because here lot of AI support will also there. So here it's inbuilt cloud software. So in while running to run the Python or deep learning algorithm, this will collab will be fine, but only the minimal data. If you are loading a data in the cloud, I hope you understand, you know that difficulty. So that the size of the data, we want to be very careful. So once we having a minimum size of data, definitely we can uh, go with the collab, or else we want to go with the Visual Studio. So this will be a fine to implement all these things. So with this, I hope if you having any queries, we will discuss, or else. Uh,
Thank you, sir. You are giving a great, wonderful session on deep learning. It's very
Thank
helpful for
you.
the researchers who are doing. Certainly, most of them taking conventional algorithms for healthcare session, ovarian
Sure.
cancer direction like that.
Okay.
Hope it will be helpful for them. Thank you for a
Definitely.
wonderful session. Thank you.
Thank you. Thank you. Thank you.
It's time to the word of thanks. Good evening to one and all. It's my privilege and honor to deliver the word of thanks for this enlightening faculty development program. First and foremost, I extend our heartfelt gratitude to our management for their continuous support, encouragement, and for providing us with the platform to organize such a meaningful event. Our sincere thanks to our respected principal, Dr. S. Manogaran, whose guidance and motivation have been instrumental in the success of this program. We are also deeply thankful to our administrative officer, Dr. V.C. Srinivasan, for ensuring all the logistics and arrangements were taken care of smoothly and efficiently. A very special thank to our chief guest, Dr. Thilagaraj, for delivering a highly insightful and thought provoking session on multimodal deep learning. Your expertise and clarity have certainly added a great value to our understanding of this emerging and impactful area. Thank you very much, sir. A
Thank you, sir.
special word of thanks to all the head of the departments for their cooperation and active involvement throughout the program. We express our deep appreciation to all the faculty members who participated with enthusiasm and made the sessions interactive and fruitful. To our esteemed participants, thank you for your active engagement and thoughtful questions, which truly enrich the discussions. Once again, thank you all for being a part of this FTP and making it a grand success. Wishing you all continued learning and professional growth. Thank you so much.
Thank you, sir. Thank you for a great opportunity. Thank you all. Thank you. Have a nice day.
Thank you, sir.